everyone, and welcome back to the Water Online Show. I am your host, Travis Kennedy, publisher here at Water Online, the leading online destination for the water wastewater market. And there's a subject that's been going around for, it seems like, eons now, but it's really only been a few years, maybe even 5-6 years. And the topic is, and tell me if you've heard this one before, PFAS. So the topic that we are going to be discussing today, and as I was driving into the studio, into the office this morning, I started thinking through, well, let's try to remind our audience before we dive into the specifics here about the deadlines. So there's two main parts to what we're going to be faced with over the next 5 years related to PFAS and MCLs. So maximum contaminant levels. There's going to be an actual numbers issue, which is what you need to get those levels down to. And then there's also a timing issue. So what does that timeline look like? When do municipalities and water systems need to accomplish what by when? So there's a lot of moving parts, right? There's a lot of balls in the air. And I wanted to just spend a minute, slow down and talk about the timing of it. So we all probably remember where we were when the mandates came down and the restrictions came down, and when the EPA started dictating exactly where we needed to be and by when. So from a by when standpoint, initially, when it comes to the initial monitoring of your system, public water systems have 3 years to complete initial monitoring for the targeted PFAS. So I believe that goes back from last year. So that takes us to about 2027. And we'll get confirmation on that when we bring in our guest for today. But public water systems specifically have 3 years to do the initial monitoring aspect of it. And then there also becomes the public notification. So we here at the Water Online Show have talked a lot about the importance of being able to have open communication to and from and with your constituents. So regulated water systems must inform the public of the level of PFAS measured in their drinking water after the initial monitoring. So that's an important piece that we don't want to gloss over. There's going to need to be an open line of communication between you and your constituents. So keep that in mind as you go through that initial testing. Not only do you have to have a grasp on where you're testing, how you're testing, what you're testing, but once you accomplish all of that and you get your numbers in, you're going to have to find a way, whether it's utilizing a PR firm or you feel you have that kind of knowledge and professionalism in terms of communication out to the market and out to your constituents. If you have that indoors within your own facility, even better. But the wording of it's going to be important. How you present that information is going to be important. And we've had guests on the show talk a lot about making sure that you are positive, that you relay positivity, and not just that the situation can be corrected, that most water systems are faced with this type of need across the entire country. It's just a question of scale. But being able to remain positive, we found the contaminants. This is the level of it. This is what we're going to do about it. So just make sure that you spend a lot of time planning that public notification aspect of the schedule coming up. So it's very important that your constituents know exactly what's going on. And then after that comes the compliance deadline. So we're talking April 26, 2029. That is the compliance deadline of which public water systems must comply with all new MCLs. Now, will that remain? Will it be changed? Will it be moved up, moved back? I don't know. I don't think anybody has those answers because there's a lot of things happening in Washington, especially with the EPA. So we really don't know for sure. But as it stands right now, and we can get confirmation of this when we bring on our subject matter expert and our guest for today, but it's April 26, 2029 is the compliance deadline. So the action required from that is all public water systems that find PFAS levels exceeding the MCLs must implement solutions to reduce PFAS in drinking water by 2029. So that is the key year. So it may seem like it's far away, but it really isn't because there's a lot to do between now and then. We're going to go ahead and bring on a subject matter expert for today. He's no stranger to the Water Online audience and to the marketplace. He is Tom Muilenberg. He is with Nora, and he's going to be able to answer some of these questions that we've gotten in here at the show that we want to find answers for you. So we're going to go ahead on the Water Online hotline, bring Tom on. Tom, how's it going today?
I'm doing real well. And yourself?
Hanging in there. Spring has sprung. So we're here in the Northeast, and we went from 80 degrees for 2 days down to in the 20s last night. And I don't quite know exactly where we're going to go next. A lot like these regulations and a lot like the MCLs, right? Nobody really knows what's going to happen next, but at least we have a baseline to work off of. And that's
Right,
what we're going
right.
to talk about today. So with the timing that we've talked about earlier, with that in front of us, I'm curious in your mind, being a subject matter expert on this, what specific steps can a water district take right now to prepare for the deadline? So when we talk about steps, that could also include what resources could be utilized. So if we're talking along the lines of steps and resources, what can water systems and water districts do right now?
Sure. So apart from the monitoring aspect, obviously that you've already spoken to, typically it doesn't take a lot of monitoring to figure out if you're going to have an issue or not. The first couple samples that you take are going to show whether or not you're over the MCLs or not. And if you are, it's highly unlikely that unless you found a brand new water source, that those numbers are going to go down anytime in the near future. So if they're above the MCLs today, likely nothing's going to change in the next couple of years, and therefore you are going to need to implement some level of treatment. So one of the things that you can start doing right away is looking at possibly piloting. If as I think probably most of our audience is aware, the most common ways of removing PFAS today are either using granular activated carbon or single-use ion exchange, and or any of a number of emerging sort of new proprietary medias that companies have out there, all using an adsorptive type methodology, and all of those work better or worse on a given water quality, not just related to the types of PFAS that you have, but also the other maybe organics, some other contaminants, or some other ions that might be in the water that compete for space on the media with PFAS. So what that means is that all of those will yield a different total cost of ownership. So if you're looking at a 10 or a 20 or longer year lifespan, the different types of medias are going to cost you either more or less in order to achieve your treatment goals. So right now, in addition to the monitoring, a great thing that you can do is set up a pilot, run small scale testing with the multiple medias, for example. So if you don't really know for sure if granular activated carbon makes the most sense for you, or ion exchange makes the most sense for you, or if some other media might be the best choice. You can actually compare, 2, 3, 4 different medias next to each other or more, and then really get a good idea. How long are these medias going to last? Which is most compatible with my water supply? And therefore work it into a replacement schedule and a cost associated with that, which then of course dovetails right into how much is this system going to cost me for the life of the system, over again that 20-year lifespan, or whatever your analysis might be. So while you're continuing to collect the information, you can kind of at the same time start narrowing down your choices and help select what is the best option for you moving forward.
So I'd like to talk about the options, but before we do, I want to just rewind a little bit. And you had talked about, yes, so the testing, you're going to know after the first 2 or 3 or whatever number of tests that you do initially, right, about your contaminants, both it does exist and what the levels are. But what is the timing there? So from when a water district starts testing to the time they get answers after the first 3 or 4 tests, like what is that? Is that a week? Is that 3 months? Is that a year? What are we talking about here?
Yeah, right now there is a bit of a testing backlog, honestly. It takes a very specialized piece of equipment to called an LCMS, or liquid chromatography mass spectrometer,
Yeah.
and to detect these various types of PFASs. And there's different levels of testing that can be done that'll yield, detections on, up to 40 different compounds. And so right now there's a little bit of a backlog on that. So typically when you take a sample and you send it into the closest lab to you, it's probably 3 to 4 weeks before you get that first analysis
Okay.
back.
All right.
And so maybe a month after your first testing, if you plan on that's probably about what you're going to see.
And how long does the actual testing last? Do you test your water for a week, a day, a month before you send it to the lab?
Oh yeah, typically you just do grab samples.
Oh, perfect.
So yeah,
Right.
yeah. So you do a grab sample. It depends a little bit on the local regulatory agencies. Sometimes just testing your raw water, or if you have multiple raw water supplies, like multiple wellheads, you'll
Sure.
test each one of those wellheads, see if there's any variation between them. If you have a single source, obviously you're just testing a single source. Some communities I've seen, though, also are testing their finished water just to see if there's any sort of drop within the system that they might be seeing. Maybe there's a little co-precipitation occurring with some kind of coagulant or something like that. Maybe it's absorbing into the coagulant. So they may actually test their finished water as well to try to get a sense of, what, if anything is going on in the plant today. And generally inadvertently.
Right.
So are
Right.
they inadvertently taking some out in the plant
Yeah.
today, and just to get a better handle on what is the water actually going to look like that needs to be treated.
Makes sense. And you had also mentioned a pilot, right? So I know there's a
Yeah.
lot of technologies out there that claim that they can fix this issue, and there seems to be more by the week. But when you mentioned a pilot project, what's the benefit of doing a pilot project now, so far ahead of the initial monitoring deadline?
I think one of the big benefits is it really helps you sort of start laying out the roadmap early,
Give you
and also,
direction, right?
yeah,
Yeah.
yeah, give you a
Yeah.
direction. And then the other thing is these pilots can take a while. So
What are we talking about time wise?
yeah, so a lot of times, if you really want to run it and really get a good idea, you want to run to the breakthrough point on the medias, and that can take as much as, like, let's say, a year to 18 months.
Wow. Okay.
Now we can do some things to shorten that cycle.
Yeah.
So if you want to look at it on a shorter time frame, typically what we're doing is taking samples throughout the column during the pilot test, and we
Yeah.
can make some estimates of, how did it perform to the 25% level versus how did it perform between the 25 and the 50% level. Then we can kind of extrapolate how long that total runtime is going to be. Now, that
Mhm.
being said, there's a bandwidth on the accuracy. So if you're only looking at part of the column, let's say your accuracy of the runtime maybe is plus or minus 2 months or something like that.
Right.
And the longer you run that, that bandwidth of accuracy gets smaller and smaller and smaller. And so, and then also you have the opportunity to pilot through various seasons. So if you are on a surface water supply that may see some pretty wide variations seasonally,
Sure.
it's great to touch all those seasons and see if there's anything that you kind of forgot about, that occurs, let's say in the spring or something. And in fact, we have a great example of one pilot where we put it online, and immediately within a week, the resin turned purple, and we said, well, wait a minute, the only way
Purple.
the only way that can be is if you've got manganese, and this is a surface water plant, and all the analyses we'd received showed zero manganese, and
Right.
customers said, oh yeah, we do get a seasonal turnover in the spring that brings a bunch of manganese up off the bottom. So the nice thing is you caught it on a pilot. It's a cheap mistake to make on a pilot versus
Yeah.
full scale. And then we
Sure.
can do some things on the pilot, like put some additional pretreatment in that emulates the full scale to make sure that we can restart it and continue to gather really good information. So you just never quite know if you want to run that entire length, that gives you really accurate information as far as how the different types of medias are going to run compared to each other, and gives you a high degree of confidence on what the right choice is moving forward.
I should mention that Tom is a product technical manager with Nora, which is one of the industry leaders and market leaders related to this type of treatment. So again, we really appreciate you spending your time here with us. And one of the things you had mentioned earlier is that there's two scenarios, right, or two examples of the, sort of the mainstream way to treat this. Once you do the monitoring and the time comes to treat, it could be activated carbon, it could be ion exchange. What scenarios would a district be faced with where it would have to choose one over the other based on their specific needs and circumstances?
Yeah, there's actually what I would consider sort of, let's say, technical aspects of the water.
Right.
Sort of, let's say, a contaminant-based challenge, and then there's sort of more of I hate to use the term soft concerns, but let's say
Let's use it.
unrelated to the water quality. Yeah.
We're unregulated here.
Yeah, yeah,
We can
yeah,
talk,
yeah.
we can use whatever we want. We're unregulated. All right, soft. Go ahead.
Yeah. So on the contaminant side, a great example, if we're just comparing GAC to ion exchange, is TOC content. So, if you have low TOC, both technologies are fantastic.
Right.
Total organic carbon. I hate throwing out acronyms, assuming everybody knows what they mean, but
I would think
but
so. I mean, our
I would
audience is pretty
think.
sharp. I'm the dumbest guy in the room, so when it comes to this kind of stuff, but I know our audience is pretty well educated on the topic. So go ahead and throw out
Yeah,
as
yeah,
many
yeah.
acronyms as you want.
Okay, got it. So like total organic carbon (TOC) is a great example. So under 2 milligrams per liter, both ion exchange and GAC work quite well. Between let's say 2 to 5, ion exchange starts to kind of be a bit of a challenge. So the TOC can really start to impact the bed life of the resin. And above 5, you really don't want to use ion exchange, and so you're
Okay.
kind of forced into using GAC, and GAC
Mhm.
will actually take out both of those contaminants, but get a little bit better runtime and a better whole life cost. So that's one example. And there's some other contaminants in the water too, sulfates and things like that can cause an issue. So a lot of times we can look at a water analysis and say, okay, between these two technologies, this is probably going to be a better fit for you, or both of them are worth investigating. Then I would say there's a classifications of sort of, let's say, soft concerns, soft costs associated with it.
Right.
And one of the things that's very interesting about GAC versus ion exchange is GAC, the loading rate, the hydraulic loading rate is right at about 6 GPM per square foot, as your default starting point, whereas ion exchange is 12 to 18. So what does that mean? That means it's about 50 to a third, 50% or less of
Mhm.
the cross-sectional area or the surface area required, meaning smaller diameter vessels. The empty bed contact time for the GAC is typically around 10 minutes. Sometimes people want to do more.
Right.
So you have very tall vessels versus just a couple of minutes for ion exchange. So you have very short vessels. So you may run into a situation where you just don't have the footprint. And so ion exchange makes more sense for you because it's significantly smaller.
Mhm.
Or you may be next to a neighborhood that is doesn't want to see really, really tall tanks. It's going to block the view of the river behind it or something like that. And so there's a motivation to keep that smaller, and then you can put it more easily into a shorter building and make it look really nice for the community. So there are some other things that come into play too, and we see this quite routinely on projects. So, you have a pumping station here, and you've
Yeah.
got their existing storage tanks there, and there's only so much space in between. It's an impractical to move a bunch of stuff. These very, very large pieces of process equipment and storage, it's very tough to move them. And so there's a preference towards the smallest system possible. And
Yeah.
so that kind of pushes you towards the ion exchange. And so that's one of the things we kind of go through with our customers a lot is to not only look at the water quality, but also look at, are there any of these other site constraints that may come into play that need to be taken into account when trying to choose the right system for them.
I mean, there's a lot more that goes into it than just will it do the job. Like you have to
Correct.
do it and also make sure your constituents are happy, not just with the quality of the water that's going to come out the other side, but as you put it, the aesthetics of their neighborhoods.
That's right.
Like where things are already pre-existing and set up. So there's a lot of thought and planning that has to go into this. So it sort of harks back to the question I had before that about why do a pilot project now? Well, it gives you a roadmap. You have to take all of these factors into account. This is not just to snap your fingers and order something, and all of a sudden it's going to be fixed within 6 months. So these things take time, and if I was to help lay out a plan, if you and I together were talking in person to water districts, municipalities across the country, I want to give them all of your expertise related to best practices. So we've talked about where to start, like what's the first step. We here at the Water Online Show are big on what is the first step and then what is the next step after that. So now we're on to best practices. So if we're talking about best practices, whether it's where the system should be placed, what kind of system should it be? What are some of the best practice tips that you could give a water district right now if they're thinking about, which they should be, going down this path?
Yeah, that's an interesting question. The I think
Best
well,
practices are always a tough question
yeah,
because it's
it
early. We don't
is.
know what's best and what isn't, right? But
Yeah, exactly. Yeah, it is actually an interesting question because there's a lot of sort of, I would say, tips and tricks that we see kind of come up on these projects. So the one that pops into my head right away is I think just about everybody always assumes that the PFAS treatment system will naturally go at the end of the current water treatment system
right.
prior to their storage or their clear well, for example.
Mhm.
And one of the things that we've noticed is that may not necessarily be the best location.
Right. All right. Do tell.
Yeah. So for example, if you have a well that maybe has a little iron and manganese in it, for
Mhm.
example, and maybe they're just currently oxidizing and filtering it out, that generally speaking, you don't get 100% iron and manganese removal. And
Mhm.
with these medias downstream that are running a very long period of time, they can start to pick up the little trace bits that come through the system. And so that can create some challenges for you in that you'll physically plug the media prior to the exhaustion due to PFAS. So in some cases, it actually makes sense to stick it right after the wellhead, where
Mhm.
the iron and manganese is still in solution. Then do your oxidation and stuff like that afterwards. So I think one of the things that best practices don't necessarily get too wrapped around the axle on whether or not that system needs to go at the very end of the train. Be prepared to take a look at, is there actually a better location in the process flow that it actually makes good technical sense. And again, I hate to harp on it, but this kind of gets back to the pilot issue too, because then you can go actually test it that way and show that yes, indeed, we get a better performance at this location of the plant than we do at this other location in the plant. Um, the other thing too is I would say remember, it isn't a standalone process. It's highly dependent on what comes upstream. So if you do have a situation where you've got organics and you've got maybe a more conventional water treatment plant, um, looking at enhancing your other contaminant removals by upgrading or tweaking your process upstream may be part of the overall solution as well. So if you might need to do a
Good
little
point.
enhanced coagulation to reduce organics, that's also an area that you can look at for improvement in order to give your best overall system performance.
Yeah. That's two
And
very
then,
good points.
yeah, and then from there, I would say, some of the best practices, you have to also think about what kind of flexibility you might want in the future. So
Yep. Good to think about.
maybe you've decided, oh, ion exchange is great for us today. Well, you might want to do it. Let's say you said, well, maybe in the future it's not going to be great. So if we have to change to a different type of media, is it easy to do with the system as it'll be configured, or do we need to do maybe a little bit larger tanks, something in
Right.
between, leave ourselves some space if we need to make a switch out later? So you kind of have to think ahead a little bit also about the future and what technologies may come up in the future that you may want to be able to incorporate into your system.
We're talking with Tom Muilenberg with the Nora, who is one of the leaders related to what many water districts are faced with right now, which is the identification, measurement, and removal of PFAS. So, Tom, I want to change this topic to something called the PFAS plume. So,
Sure.
related to that, what techniques or preparation activities can a district use to mitigate the plume in groundwater specifically?
Um, Yeah, that's actually kind of an interesting question also. First of all, I think,
I got a lot of those. I am full of interesting
yeah, yeah,
questions. They
yeah,
may not
yeah.
be great questions, but they at times can be interesting, as in, why are we talking about that? Well, we think it's important for our users and water districts and municipalities to be well prepared for anything that they may face down this journey. And you certainly, Tom, are the man to help walk them down this path. So,
Well, thank you. Um, uh, I'd say there's a couple aspects of it. So, there's the plume that's already, let's say, in the ground. So
right.
obviously that plume got there somehow. So
Somehow it did. Yeah.
one is identify if you can identify where the source of that plume is, and is it still active?
Yeah.
Do you have a manufacturing facility nearby that's been discharging and that's adding to the plume? Obviously, you're going to want to have conversations with them about how to mitigate adding any more into the environment. So that's a big aspect of it. Also, as I'm sure you're aware, there's a lot of work being done in things like landfill leachate applications, where you're
Sure.
intercepting the water from the landfill and removing the PFAS there. So at least you stop that PFAS, or at least intercept that PFAS from like a landfill getting into the system. So there's a lot of work being done in that space as well to try to reduce what's being added into the environment. Then, as far as the plume that's actually already in the ground, I mean, it's just going to take a lot of time to migrate through. And
Sure.
there are some things that are used from time to time, depending on the type of contaminant. So I haven't really seen it necessarily for PFAS yet at this point. I may just be unaware of it. But a good
I
example
doubt
is
you're unaware of it. I doubt
yeah,
you're
yeah.
unaware of it. If anybody would know, you
I
would.
might be unaware of anybody doing it, but I know that for other types of contamination, like the use of colloidal powdered activated carbon,
Mhm.
has sometimes been used. And what they'll do is you inject it, let's say, below the rock and the dirt and above the aquifer. And
Right.
so you inject it into the strata, basically, to create a absorption layer within the gradient
Mhm.
of the above the aquifer, and so you inject it in there and try to intercept that plume before it gets any worse in your aquifer. And so I think now whether or not anybody would actually do that today, I don't know, but it is a mitigation technique for other types of contaminants that create these plumes. So that might possibly be an option. But unfortunately, I have to say, in most cases, we're probably just going to be dealing with the plume for decades as it works its way through the geology and eventually into the aquifers and out. But I
Yeah.
think a combination of reducing and eliminating the point sources to at least not add any more into the environment, as well as just the advantage of time. Eventually, it'll work itself through the system, but it's going to be a while.
To quote Jurassic Park, nature always finds a way.
That's right. Yeah.
Last question here that is specifically related to instructions and tips for our water districts out there. What tips do you have for any districts out there on how they can evaluate the effectiveness and efficiency of a removal system to varying
Yes.
factors?
So the interesting thing is the effectiveness is actually fairly straightforward.
Sure.
The really nice thing about these media is as long as the media is fresh, when you put it on and you start taking those analyses, you'll just actually the data is quite boring. You'll just see below detection limit on your various PFASs for some number of months.
Right.
You know, we're,
Success.
yeah, we're all used to seeing these presentations where you see, oh, here's the raw water and it's zigzagging all
Right.
over the place, and here's the finished water and it kind of does this thing, and oh, there's a blip here that corresponded to a rain event. Nah, it's
Mm.
actually pretty boring data. It's here's the inlet, and then
Right.
here's the outlet. It's just this sort of flat line down at the
Yeah.
bottom.
But simple to understand, right? I
Yeah,
mean,
it's at least it's
yeah,
easy to understand. That's
sure.
exactly right. And then as far as like the efficiency is concerned, what it really comes down to is it comes down to, okay, where do each of those media start to break through? And then you've got that time frame in between your start and where you start to see that breakthrough, and then of course that just plugs into a calculation to tell you, okay, this is how much it's going to cost you to operate. Now, one thing I will also say as a tip and as sort of a tip and trick, is we've seen a decent amount of variation with communities on what their actual treatment goal is. So if you some communities will say, look, I'm regulated on the regulated contaminants. That's all I really care about. And so the 6 contaminants are what I'm going to really be monitoring and controlling my system off of. And if I see
Right.
a couple other weird little PFASs sneaking through, I'm not really going to control my system based on that. But some communities are like, look, as long as I have a treatment system there, I want to get all the PFAS out,
Sure.
whether it's regulated or not.
Yeah.
And
Smart.
yeah, those are two
Smart.
different treatment goals because you
Right.
may see like, one of the PFH excesses kind of sneaking through early, and if that's your control point is no PFAS ever, that changes that runtime. And
Sure.
so I think that's another tip is understand what it is that your treatment goal actually is today.
Yeah.
Is it to take it all out, or is it just to deal with the regulated contaminants? And the good news is like if you change your mind in the future, let's say you say I'm only worried about the regulated today, and you change your mind in the future, it doesn't change the equipment. It just changes how frequently you're changing out the media. And so it's one of those things that you can then take that look at that data and say, okay, if I change my mind and I want to take it all out, or something else gets added to the regulations, you've got this data that shows when these various species are breaking through, and then you know right away, okay, this is what it's going to cost me to meet this other goal.
Yeah. I mean, it's there's a lot of things to think about, right? And I don't know if water districts have a full picture as to all of the check boxes that they're going to need to go through and why it's so important that they start now.
Yeah.
So, I mean, we certainly appreciate you coming on air here with us, giving these water districts, water utilities a chance to sort of check in, get an idea from an expert on, all right, so what is my first step? And then what is my next step? And then what is my next step after that? So, a lot of times throughout this interview, you've talked about what we've seen, and you've used the term we've, and what he's talking about when he says we is Denora. So, if our listeners out there wanted to get more information on how Nora can help them along this path, where would you send them?
Well, a great starting point is our website, of course, which is
Or
quite easy,
yeah,
www.denora.com, denora.com. It's got great information there. Also, various methodologies to reach out to us and request information. If somebody wants to contact me directly, my email is tom.muilenberg@denora.com, and that's tom.muilenberg@denora.com. And then I can either help you directly or get you in contact with the right person within our team. And those are probably the easiest, quickest ways to reach out to us.
Drew, there's a third way. Denora is well represented on Water Online. So if you want to
Oh,
contact
yes, of
through
course.
Denora, through Water Online, feel free to do that as well. We'll make sure we get the message to Tom directly. Tom, thank you very much for joining us here. It is so refreshing that every time that we have a guest on to help a lot of our utilities and our operators, engineers go through this process with them. And we've had a lot of good guests, all of them, including you, have just been incredibly informative. The direction you gave, the specifics you gave, the things that I wasn't even thinking about, but that's no surprise. But I'm sure it gave a lot of our listeners and our viewers something to think about so they can start planning now. Tom Muilenberg with Nora, thank you very much. We appreciate you joining us. And for all of you out there, we appreciate you spending your time here with us. All of us here at Water Online, we look forward to seeing you next time.